Question 22. A conical cup has dimensions as shown in the diagram of its cross-section below. The cup can hold a maximum volume V when filled to its full depth H. Find an expression for the depth H to which you have to fill the cup so that it contains a volume of liquid equal to V over 2. Your expression for H should only depend on the dimensions of the cup. So first, the volume of a cone is pi r squared H over 3, which means in this case V, which is the volume of this cup, equals pi, the radius will be d over 2, and the height is h over 3, which is 1/12 pi d squared h. Okay, so that's a good start. And we want some kind of value for h where this volume is V over 2. And just for now, let's call the diameter little d. So what we can say here is, using this equation, that V over 2 equals 1/12 pi little d little h. Okay. And then combining these two equations, what we get is that 1/24 of pi d squared h equals 1/12 pi d squared h. And from that we get, I'm going to write this up here now, we get d squared h equals 2 d squared h. Okay. So now we need an expression for h, but we need it in terms of big D and big H, not in terms of little d, which is a variable we've just sort of made up. So what's the relationship then between the variables? Well, if we call this angle theta, you should see that using triangles, that tan theta over 2 equals d over 2 over h, and also big D over 2 over big H. Or in other words, d over h equals d over h. Or rather, little d equals little h, big D over big H. So then if we sub 2 into 1, what are we left with? Well, we get d squared h equals 2 lots of h d over h squared little h, and we see that the d's cancel, which leaves us with capital H to the 3 equals 2 little h to the 3, which means that little h equals 2 to the minus a third h.